Okay, there we go. Between the ammonia gas and the sulfuric acid as follows. So what volume of ammonia gas measured at 78 Celsius in a pressure of 1.66 atmospheres will be needed to produce 5.00 times 10 to the third grams of NH4, so ammonium sulfate? Using the atomic mass values from the periodic table, you get the molar mass. So you calculated that. And from there, you can figure out how many moles. Once you have the moles, then you can use the ideal gas law constant to calculate that volume. So like in this case, we found out that it was 75.68 moles of ammonia and 37.48 moles of ammonium sulfate. Okay, so what they gave us, you just need to figure that out, and then from the stoichiometry, we can figure out how many moles or mass of ammonia we need, depending on what they're asking. In this case, it's asking for volume. So the next thing to do is to use the ideal gas law to calculate it, right? And under the stated conditions, which they're up there, we need to solve for V. So don't forget to convert that temperature to Kelvin and substitute the quantity. So you got these, and the volume is 1,310 liters. Remember also to stick with your sig figs. And in this case, the sig figs come from the two quantities, the mass and the atmospheres, because temperature usually does not involve that. Okay. All right. So here's some practice problems, and these practice problems are going to be your homework, and I'm just running through them. And that's it. Okay. So to go back, if you want to start doing your homework, we have these. Right? And we have also these, sorry, there we go. So there's an example. It shows you how to do it. And then on the next one, you have your practice problems. You have 4 of them. I can copy and paste them on a document if you want. I think I'll do that. Yeah, I think I'll go ahead and do that. And you guys can start doing it now. So these are going to be your mass with ideal gas law problems. Oops, I don't want that. I just want the problems. Stop. Sorry. There we go. That's what I was trying to do. I'm just going to put them on a document on a Word doc. Okay, and this is going to be known as the practice problems. So like I said, these are your assignment that you're going to be doing. So it's really about 6 or 8 problems, I think more like 8. So the first one is ideal gas law, but we're going to say, and remember it says using mass with ideal gas law. Okay. There are your problems. And then the other one is going to be the second ones. So let me go copy those. And that's these right here. No, that's the same one that I already got. Sorry, wrong one. Oh, come on, get down. There we go. And here they are. See, there's two more, but there's another page. So yeah, there's more than two. So like I said, I think it's 8 total. And then this one is got stoichiometry problems. Stoichiometry. Oh Lord, why did I write? Stoichiometry problems. That's one. And then there's another one. Okay. Another sheet. Yeah, I guess that was it. No, there's one more, right? Thought there was one more. I guess not. No, there is two. And that's the other two. Yeah, here we go. Okay. And that'll be your assignment for today. Where am I? Okay, here. All right. And that's 8 problems total. All right. So it's the same thing that is on the PowerPoint. So if you want to go ahead and like this, no. There we go. Now let me go back. That is weird how that's set. There. Lord, where's my code? There. I meant to go here. And then 4. It's just weird how it's got. See, I guess it's because it was done for the PowerPoint. So all of this stuff is weird. The other ones, see, the same thing. So it fits better over there. Okay, it does look okay. Let's see this one. There we go. Please. Okay, I need to fix these. All right, so you guys are going to go ahead and start working on these if you want while I'm here, so you can have questions. I think this is gonna fit there. No. Okay, there we go. Now this one needs to move over. There we go. I can fix some stuff, but it's a little time. Make it easier for you guys to see it. All right, and there you go. Oh, one more. Okay, so these are your questions. Do you want me to leave this like this, or do you want me to go and do the PowerPoint instead so you can read it more better? Okay. Let me make it bigger too, so you can see it. All right, so try the first 4 and see what you get. And this is also your homework. So if you don't finish today, you can always do more later. But that way I'm here while you do the problems. And you have questions, I can answer them. Okay, hold on. Okay. There you go. Gas lines. There we go. There. Oh, here we go. Okay. I fix this too. I'm picky while you're doing that. Get all this fixed. I just noticed there's no arrow. Oops, sorry. Oops, did I move it? I'm just trying to hurry up and get this done for you guys. Okay, one more. This one won't take long. It's just one thing and then this. I think that's it, right? Okay, now you can read it again. Mhm. Okay. You guys are- If you want to share your answers, just put the problem number and the answer on the chat privately so nobody else sees it. And I'll tell you if it's correct or not. Okay. You're so cute. Mhm. Okay. By now you should all have at least the first 4 done, I would hope. But nobody else has shared except for Christina, so I need all of you to start sharing your answers. Charlie. Stop it. Stop it, Tito. Push. Yeah. What? No. Okay. Oh, I haven't done that. Okay. Yeah. Okay. Something's weird here. Charlotte, be quiet. No, no, go. when you turn these in, I'm going to require you to show your work, but right now, at least you know that your answers are correct, which is good. Okay. What do I do with 4.245 grams? Okay. All right, here we go. All right, for that, Christina, what you have to do is you have to first balance your equation. This equation right here, right? This one. Balance that equation. After you balance it, then the grams you can convert to moles of aluminum. And from the aluminum moles, you can figure out how many moles of hydrogen you're going to produce once the stuff is balanced. Correct. But first you have to figure out your moles of aluminum. So remember, you use the molar mass. So let's see, let me show you. Let me insert a little thing. Okay. I know I had numbers. Okay, no, undo. I don't like that one. I didn't want it there anyway. No, undo. There we go. Don't want it there. Yeah. No, I want it down here. That's why I moved it. Okay. So now let me insert the table right here. So basically, you have 4.425, right? 4.245 moles of aluminum, right? For every, now you need to say that for every mole of aluminum, you have how many grams? 30, 20, 26.98 grams of aluminum, right? Oh wait, that was grams. Sorry, backwards. Okay, this needs to be on the bottom. Grams of aluminum per mole, right? So now, from your equation, you have that for every, where's my balanced equation? For every 2 moles of aluminum, you produce 3 moles of H2, right? And that's how you do it. And then that's how you get your moles. Okay? Let me see. You should get, and don't forget you need 4 sig figs. Oops. 0.236. Is that what you got? Okay. Now from there, you just inserted the moles of that into your PV equal nRT, solve for V. So V is equal to, nRT T over P. And then you get your volume from there. Okay. Don't forget to use the correct R too, because we have different R's. You're welcome. No. No. Okay, you needed to do nRT. So N would be the number of moles, which is this, right? Okay, so let's see. So where V is going to be equal to, equal to number of moles, right? Times, we got the R, which is 8.314. And I'm not going to put units right now, but you should. And the temperature, which needs to be in Kelvin, and that's 288. And then that, right, all gets multiplied first. And then that's divided by the pressure, which is in kilopascals, which is 94.4. And that is kPa. Okay, and that's how you do it. So that should give you the right answer. Yep, that's what I got. Okay. Yeah, there we go. And you should, yeah, correct. And since the number of moles that you got only had 3 sig figs, you should limit that to 3, but that's good enough. All right, good. Same thing for the other one. Same thing. You just got to do I know. After you do the that's a 1-to-1. Is it N2 or N02? I think it's N2, right? Yeah, N2. Okay, so that's going to give you the same number. So whatever that is 12.2 divided by 80.06. That gives me the number of moles, so 0.152. This one only has 3 suffixes. Okay, so after you balance into yeah, that's balanced. Okay, so then that times the pressure, the volume, I mean, it says, what is it asking for? What volume again? Yeah. Okay, so that's going to be 8.314 times the temperature, which is 14, which is 287 this time, right? Divided by your pressure, 998.5 kilopascal. Okay, I'll see what I get on that one. All right. Six. Hmm. Two. Make sure I got that one right. I think the molar mass is 14.01 times 2. 4 times 1.01 plus. I got 3. 2 and 4, yeah. 3 times 16. 80.06, yeah, that's what I got. 0.152 moles. Okay. Oh, it's for 2. Huh? I did not see. No, that is 1. Never mind. No, that is 1. 1-to-1. Okay, so 152. Yeah, 27. I don't know. Not getting the right answer there, but I should. I said 0.152 times 8.3 and 8.341 in it. 314 times 287 divided by 99 point, no, 998. 0.363. I get 0.363. Why do I get that? It doesn't feel right. That is that problem. Yeah, that's this one. 0.363 liters is what I get. Okay. 26. Okay. Determining mass of CS2 in grams. Okay. Required to produce 157.7 liters of SO2 at 25 Celsius and 99.4 kilopascals. Okay. Yeah, of course. Equals equal to nRT. And it's going to be PV over RT. So pressure times volume 15.7 divided by R 8.314 times T minus 25. 90. Okay. Clear. And 9.4 times 15.7. Let's see, that was 630 of SO2. Okay, so we need to balance that equation. It's 2, so we need a 2 here. And then that gives us 6 O2s, right? So that's a 3. No. Okay, so for every 2 moles of SO2, we produce 1 mole of CS2. Now, 1 mole of CS2 is equal to what? That's 45. No, 500. Plus 2 times 2.7, I think. 76.15 grams. Okay. Clear. So 0.63 times 76.15 equals divided by 2. 24. Yep, I got that one. 24.0 grams. CS2. Okay, I got all of them. Are you getting, what are you getting for number 3? I mean, number 2, Christina, because I'm getting a totally different answer than what but sometimes they have typos, so that what I have on my thing here, but I always check it. Yeah, that's what I get. I get 0.363. Yep, that is correct. That's what I get. So two wrongs can make a right, right? Did you get your molar mass 80.06 for ammonium nitrate? 80.06. Okay. And yeah, and the balanced equation is 1-to-1 ratio, right? Okay, that's what I got too. Okay. So maybe I miscopied it. Let me check, because I have that problem sometimes too, that I've done, I think I gotten the numbers and maybe it says 122 or something like that. Let me make sure I got it right though. I don't think so, but you never know. With me, you just don't know. Let me see, 14, where are you? And this is problem 24. 24. Yeah, I have 12.2. Oh, there it is. There's the problem. Not one too many nines. There we go. That makes sense. Everything else is right. See, I told you I might have done something wrong. Okay, so now it should be all right. All right, so just 12. We ended up with 0.152 times 8.314 times 287 divided by this number instead of that one, 98.5. Yay, I got 3.68, which is what it says. I was like, 3.68 liters. Okay, I thought that was kind of high pressure, but there you go. That was the problem. I put 9985. That's why it's always good to check. Yeah, but everything looks good. Yep. And the last one, it wants you to write a balanced equation and then calculate the mass needed to produce that much. Okay. So it's the same thing, but first you got to do the balanced equation. And potassium chlorate is KClO3 and KCl plus O2. Oh yeah, that's easy. That's an easy equation. KClO3 changes to KCl plus O2. So we need to put a 2 in front of that, a 2 in front of that, and a 3 in front of that. Okay, got it. All right, next. Let's see. Okay, 5.0 times 10 to the second milliliters of oxygen gas. Okay, so 5.00 times 10 to the second milliliters. Yep, of oxygen gas. Okay, so 10 to the second times this is 1, 2, so it's half a liter, 0.5 liters. Okay, so that's our volume. All right, Let's see what we get. Space over here. Hold on, let me just do it right there. Okay. So the N we want is PV over RT. So our pressure is 90, right, where'd it go? Oh, 1.108 atmospheres. You notice this time we're going to have to change. Our volume is 0.5 liters, right? Divided by our R, which is going to be 0.0821. And our T temperature is 39. What is 39? 273 plus 39. 312. Okay. So let's see where we get here. I got N is equal to 0.0216. And we only had two, yeah, okay. All right. So moles of O2. So we need how much potassium chlorate we need. Okay. So if we have moles of O2, we have 0.0216 mole 2 for every mole of O2. Let me see, every 3 moles, I think it was. Where's my equation? Yeah, for every 3 moles of O2, we get 2 moles of KCl. This is potassium chloride. Yeah. Chlorate. No. 2 moles of KClO3. Okay. 1 mole of KClO3 is equal to, I don't know how many grams, but we'll find out. Right. K. Okay. KClO3. So K is 39.1 plus Cl is 35.45 plus O3 is 3 times 16, 122.55. Okay, so 122.55 times 2 times 0.0216 divided by 3. And I get 1.7 or 1.8, 1.76, whatever. See what they got in here. I think it's 1.76 also. Yep. Yes, 1.77. Yes, we did it. We finished them. All right. There you go. All right, so you've done your homework for the day. And I hope everybody else has finished theirs. I will go ahead and write you in. Oh, I'll just take this off too. And I'll just be posting these up there, but I'm not posting this. This is the answer. I want to see all of your work. Okay. All pronouns. Okay. All right. That's it. All righty, Christina, thank you for being here. And you too, Christopher. Did you get any of these problems done?
Yes, ma'am.
Good. Then you have half your homework done already, probably, huh?
Yes, ma'am.
Did you get good answers? You never
I believe
shared.
so. I was still working on the questions. I'm kind of like still grasping the concepts.
Oh, okay. I got you. Well, you can always,
Yeah.
this is why I'm here. You can always
Yes.
ask me if you don't
Yes.
get something. All right. Well, you all have a wonderful Easter, and I will see you Tuesday.
Okay. Thank you, Dr. Vitz.
You're welcome. Bye-bye.